We want to talk about the transit of Mercury, which is going to happen on the 11th of November 2019 this year. It so happens that's Veterans Day. And what will happen on the 11th of November is the little planet Mercury, let's say this is the Sun, the little planet Mercury will pass in front of the Sun from our point of view on Earth. And since Mercury is between us and the Sun, and it's moving between us and the Sun, that's called a transit, and that's why we call it the transit of Mercury. We see Mercury pass in front of the Sun. Now, the transits do not occur all that often. The next one will be 13 years later, on the 13th of November in the year 2032, and then there'll be another one on the 7th of November in 2039, and neither of those are visible from the U.S. They're not visible from the U.S. If you want to see them, you have to either be in Africa or parts of Africa or parts of Europe. The next one that's visible from the U.S. is going to be on the 7th of May in 2049, and I'll be over 100 years old then. You'll notice that these transits occur in May or November. So why does that happen? Why do we only see transits of Mercury in the months of May or November? So in this sketch, here's the Sun, and this represents the orbit of Mercury. From our point of view, in the month of November, in a few days in the month of November, we're out here, and we see, if we could see the orbit of Mercury, we would see that it passes in front of the Sun. And it so happens that in this November 11th of 2019, Mercury will be at that point in its orbit. In other Novembers, it may be here or somewhere else in its orbit, but this time everything lines up right, so we see the transit of Mercury. You go 6 months later, you're on the other side of the Sun, so if you imagine the Earth being in the board and looking out from the Earth, you would then see the orbit of Mercury across the Sun, and transits will occur in the month of May if Mercury happens to be in the right spot. So the Earth has to be in the right spot in November or May, and Mercury has to be on the right spot of its orbit in those months. So why are transits interesting? When I was growing up, there were 9 planets. I'm still counting Pluto. I'm old enough to count Pluto. As a result of work done with the Kepler spacecraft, there are now 3,000 plus, it detected 3,000 plus what are called exoplanets. And these are planets outside our solar system that orbit other stars. So let's say out here, here's the Earth's orbit, and so here we are on Earth. And there's a star out over here. And there may be a planet orbiting that star, which we'll exaggerate the size of. And when that planet passes in front of the star's light will dip. And that's how these planets are detected by the Kepler spacecraft. So when Mercury passes in front of the Sun on the 11th, the Sun's intensity will actually dip a little bit. You'll never notice it, it's so small. But the sensors on the board, the Kepler spacecraft, are sensitive enough, so if planets pass in front of a star, planets that are orbiting a star pass in front of the star, from the spacecraft's point of view, it will see a dip in light, and that indicates there's a planet. So that is why transits are interesting, for being able to explain how exoplanets are seen. So what will happen on November 11th is shown here in this diagram. The large circle represents the sun. This path beginning over here and going across just above the center of the sun and across to the other side, that's the path that the planet Mercury will follow on November 11th. We'll begin crossing the sun at 7:35 in the morning. It will be closest to the center of the sun at around 10:19 in the morning, and then it will leave, from our point of view on Earth, it will leave the face of the sun around 1:03 in the afternoon. And I call this almost a bullseye transit because Mercury passes very close to the center of the sun. So that makes the transit time very long. It's going to take roughly 5.5 hours from the time Mercury starts crossing the sun until it leaves the sun. Now Mercury will appear as a very tiny disk crossing the sun. Here's roughly, not exactly to scale, but roughly to scale, the size of the sun and how big Mercury will look. It will be nearly 200 times smaller than the sun. So in other words, if you took that little circle, you'd have to put, that little disk, you would have to put 200 of them all the way across to go across the sun. I am going to be watching the transit. I will be using a telescope like this. And in order to safely observe Mercury transiting the sun, I have a full aperture solar filter that will go on the front of the telescope, and that will allow me to observe the sun safely. I also have a smaller full aperture filter that goes on the finder scope to make it easier to find the sun. So this will make viewing of the transit safe. If you happen to have a pair of solar eclipse glasses left over from the solar eclipse in August of 2017, you might try to see Mercury using the glasses. And if you do that, I would suggest the best time to try seeing it will be when it's closest to the center of the sun, because then you will know where to look on the sun to see Mercury. Another way to observe this is to simply go online, and I imagine there'll be live streaming from different observatories, different systems, to observe the transit on the 11th. Now it turns out that Mercury, if we come back over here, Mercury passes between the Earth and the Sun 3 to 4 times a year. But we don't have a transit every time it passes between the Earth and the Sun, because from our point of view it may be above the Sun or it may be below the Sun. And if we say, okay, here's the sun, I want to try to show you now why it is 3 to 4 times a year. So here's the sun, and here's the orbit of Mercury, and here is the orbit of the Earth. In between is Venus. We're not going to bother showing Venus. And we'll take as a reference point November 11th. And then we can say some angle theta Mercury, where Mercury would be. And that angle would be the number of days that have passed times 360 degrees over the period of Mercury's orbit of 88 days. So starting here, and if we go for 88 days, we come back to here. Go another 88 days, we come back to here. And that will happen roughly 4 times with the Earth going around once, and I'll show you that in a second on a diagram. And so we would have a similar expression for the angle for the Earth, say to Earth. Would be that angle, and that would be the number of days times 360 degrees over the period of the Earth's orbit, which is 365 days. So if we go 365 days all the way around, we come back to 360. We go 360 degrees all the way around. So over here on this diagram, we show that. So on the bottom scale is a year number of days. We're going to start day 0 on the 11th of November 2019. That's the day Mercury transits the Sun. And we're showing the angle here. So we're starting out at 0, 0 for both Mercury and the Earth. And as Mercury goes around 88 days, it will come back to 360 degrees. We start over again. Another 88 days, goes 360 degrees. We come back again. Another 88 days, and so on. And where the Earth's timeline here intercepts that of Mercury, that is when Mercury is between the Earth and the Sun. And you can see that occurs 1, 2, 3, 4 times. The next time it occurs is the 25th of February next year, 2020. But at that time, Mercury is going to be 3.7 degrees above the Sun, so there will be no transit. In June, 30th of June 2020, Mercury will be 4.4 degrees below the Sun. Again, you won't see a transit. The next time we have this intercept here, it's going to be the 25th of October 2020. We're getting very close to November now. So Mercury is only going to be a small fraction of 0.85 degrees below the Sun. So we're coming up on November. So we almost have a transit, but we're going to miss the Sun. Mercury will miss the Sun by 0.85 degrees. So that is the story of Mercury transiting the Sun on the 11th of November of 2019.